Hello and welcome to Section 7. Section 7 is titled General Rules for Polynomial Equations. You should have a handout to follow along with these notes. There are 5 basic theorems or rules that we're going to talk about. The first one, and this is an exciting title, is the fundamental theorem of algebra. Doesn't that sound exciting? Read along with me as I read it. If some function p of x is a polynomial with degree n. So n, could be 1, first degree, second degree, third degree. With complex coefficients, that just means numerical coefficients, essentially. Then the equation, if it's set to 0, has exactly n roots. So a double root counts as 2 roots. Triple root counts as 3 roots. So if the degree is, 6, then it has 6 roots. So here in the first example, if the degree is 5, then it has 5 roots total. We don't know what those roots look like. We don't know how many are complex or how many are real, but we do know that it has 5 total roots. That's what the fundamental theorem of algebra says. Pretty exciting, huh? All right, the second theorem we're going to talk about is the complex conjugate theorem. If p of x is some polynomial with real coefficients and a plus bi is a root when the function is equal to 0, then with a plus bi as a root, you also have a minus bi as a root. So for instance, in this first example, it's a cubic polynomial. The first root is 4 plus 2i. Well, if 4 plus 2i is a root, that's right, you guessed it, his buddy is 4 minus 2i. Those complex numbers, they're kind of insecure. They always have to have a buddy with them. If we were to write this out in factored form, it would be the following. It'd be x minus the first root, but remember the first root is a complex root, 4 plus 2i. This is just like, if x equals 7 is a root, then that means x minus 7 is the factor. The second factor would be x minus 4 minus 2i. And then the third factor, since it's a cubic polynomial, would be x minus some root r, whatever r is. Notice here, the third root must be real. The third root must be real. Think about that. Because it's a cubic polynomial. That means one arrow is going down and one arrow is going up. That means at some point it has to cross the x-axis. At some point it's got to cross the x-axis. That goes for any odd degree polynomials. Cubic polynomial, quintic polynomial, something to the 5th degree, to the 7th degree. And this is true for 2 reasons. Remember, complex roots, this idea that we've been talking about, complex roots come in pairs. Complex roots come in pairs. That means if you have a plus bi, then you have a minus bi. And secondly, cubic functions must have one real root. Cubic functions, and really we could say anything odd. Remember, cubic function, that's where n is 3. Cubic functions must, capital must, have one real root. We already said that. Because it's an odd degree, one arrow goes up, the other arrow goes down. It's got to cross the x-axis somewhere. Maybe even in 2 places. But the point is it's got to cross once. That's the complex conjugate theorem. If 4 plus 2i is a root, 4 minus. Here's the third theorem. It's really a corollary, which is like a theorem. If p of x is a polynomial of odd degree, so that's n equal 1, n equal 3, then the equation has at least one real root. That's essentially what we said before. So for instance here, this is 7th degree, okay? That means it must have one root. It must have one real root. Must have one. It could have 3 because they come in pairs just like the complex roots. It could have 5 or all 7 of them could be real. Okay? For complex roots, if all 7 of them are real, then it could have 0 complex roots. Could have 0 complex roots. If Or if it has one complex root, it's got to have two because they come in pairs. Or if it has two complex roots, then it's got to have four because they come in pairs. Or you could have 6 complex roots. Notice the complex roots are always even numbers. Even numbers. So here are the scenarios. Let's say it only has one real root. Remember, it has to have a total of 7 since it's 7 3. That means it would have 6 complex roots. Let's say it has 3 real roots. Well, then it would have, its total must be 7, so it would have 4 complex roots. Let's say 5 of its roots were real. That means only 2 of them would be complex because it must have 7. Finally, what if it had 7 real roots? Well, then all of them are real and none are complex. None are complex. Complex roots come in pairs. Okay, Theorem 3. Let's read this one together. This one's a lot like the second one that we did. If p of x has rational coefficients here. Rational, not just real, rational. That's an important word. Underline that. Remember, rational is anything that can be written as a fraction, a over b, with no radicals. Any number that can be written as a fraction, a over b, like 1/2 or 6. That's important for one of your homework problems tonight. And a plus root b is a root, then a minus root b is also a root. So for instance, if 3 plus root 2 is a root, then 3 minus root 2 is also a root. 3 minus root 2 is also a root. Here's what the factors would look like. They're kind of crazy because the factors are binomials. Anyway, x minus 3 plus root 2. And x minus 3 minus root 2. That's what the factors would look like. And then if you wanted to multiply that out, you could. You'd have to distribute the negatives and do the distributive property. You're going to have to do that, I think, in 1 or 2 problems in your homework. Not too bad. Okay, and the last one, and this is the most important one for the section. It's the one that you're going to use the most. So for some polynomial, see it right here? Here's a sub n. That's the leading coefficient. A sub n minus 1 is the second term. A sub 0 is the constant. The sum of the roots, no matter what they are, the sum of the roots, so when you add the roots, it's always equal to the opposite of the second term divided by the leading coefficient. Opposite of the second term divided by the leading coefficient. You're going to see this in action here in a little bit. Let me write that out for you guys. Okay, so this is the second term, and then a sub n, that's the LC, leading coefficient. Leading coefficient. And you always do the opposite of it. That's why it's got the negative. The product of the roots is equal to the constant divided by the leading coefficient. If the degree is even, it's equal to the opposite of the constant divided by the leading coefficient if the degree is odd. Now that sounds like a lot, but it's really not that bad. So again, a sub 0, that's the constant. Write that out. N is just the degree, whatever the highest power is in your polynomial. And a sub n is the LC again, the LC. So let's see this stuff in action. Are you ready? Here we go. I'm going to erase these notes that I made up here. Maybe, if it'll let me. So it let me erase the white. It's not letting me erase the blue. And I don't understand why. Well, regardless, we can still do it. Okay, so here's a polynomial. 2x to the 4th plus 3x cubed plus x squared plus x plus 4. Find the sum of the roots. Alright, the sum of the roots. Let's see here. I got a formula here. Here it is. It's negative of the second term divided by the leading coefficient. So the opposite of the second term, that'd be negative 3 over the leading coefficient 2. Negative 1.5. That's the sum of the roots, whatever they are. Remember, there are 4 roots. They would add up to this number. The product of the roots, now here, n is even. N is an even number. N is even. So you got to use this one right here, a sub 0 over a sub n. So that's the constant, a sub 0 over a sub n. The constant is 4 divided by the leading coefficient, which is 2. Answer 2. That's the product of the roots. So the 4 roots, whatever they are, would multiply to get positive 2. Would multiply to get positive 2. Okay, so let me shrink this for a second, and let's do another example. This is number 6. Here's the polynomial. P of x is 4x to the 3rd power plus 2x squared plus 3x plus 1. Okay, now we've got an odd degree here. I want you to find the sum of the roots. Well, the sum formula doesn't change. It's the opposite of the second term, or the second coefficient divided by the leading coefficient. Alright, so the second coefficient is 2, so the opposite of 2 divided by the leading coefficient, which is 4. So that is negative 1/2. The sum of the roots would be negative 1/2 again. Or not again, that's not what we got last time. The product of the roots, now this one, it depends upon whether you have an odd degree and an even degree. We've got an odd degree. Odd degree. So that means my formula is not the constant divided by the leading coefficient. It's the opposite of the constant divided by the leading coefficient. Well, the opposite of the constant is 1. So the opposite of 1 divided by 4. Boom! There's the product of the roots. So the 3 roots from this polynomial, whatever they are, would multiply to get negative 1/4. And you say, well, big deal. Well, we can use this to help. Specifically here in number 7, we can use it. So find a quadratic equation with roots negative 2 and negative 4. Roots negative 2 and negative 4. Okay, well, if the roots are negative 2, or is negative 2, what's that mean a factor is? What factor would have given you negative 2? It would be x plus 2. And the other factor from the negative 4 would give you x plus 4. And now notice, guys, it said a quadratic equation. That means the degree is 2. Well, sweet, we already got our factors. We can find our quadratic equation. Here it is. X squared plus 6x plus 8 is 0. Cha-ching! All I did was FOIL. All I did was FOIL. And I want you to notice something here. Break down the 6. You get negative 2 plus negative 4 is negative 6. Why is that significant? That's your formula, guys. Look. It's the opposite of the second term divided by the leading coefficient. The opposite of 6, or positive 6, is negative 6 divided by the leading coefficient. That's the sum of our roots, negative 2 and negative 4, the sum of our roots. And check out the 8, break him down. That's negative 2 times negative 4. That's the product of our roots, which is 8. The product of our roots is 8. So for quadratic polynomials, it's real simple. It's always x squared minus the sum of the roots times x plus the product of the roots equals 0 every single time. It's minus the sum of the roots, remember, because you got to do the opposite of the sum. All right, let's use this to help us out here. We're going to use this to help us out in the next video. So get ready for the next video, 2-7 part 2. I'll catch you later. I'm out.